Just give me a second. I'll put in my classroom. Yeah, I'm sharing my screen. Okay, so here in the classwork, you can see I have uh, uploaded till 6 practicals. So this one, the analyze the cardiac signals data. So the link I have given here, you can just go to the, it's already uploaded in Kaggle. This is the heart signals. The questions I have yet to upload. The projects I have uploaded, which I have done in the class. Okay, so this one, then identification of fracture. We had done the bone fracture data set, bone fracture detection. So this is the bone fracture detection. Sorry, this is the data set. Okay, so this one, bone fracture detection, to change the name. Okay, so this was about the bone fracture detection data set. And then we had this RNA mutation data set where we had done it in, I have done it in the local computer, so I have uploaded the PDF. Okay, so one thing I want to tell you, please inform this to your colleague, the classmates also. The first 3 practicals, 1, 2, 3, which I have sent, and this is already there, and the rest I'm yet to upload the assignment. These 3 will be graded in the sense I will give marks on this 10, 10, 10, 30 marks. Okay, you have to upload the PDF. Why you have uploaded the PBIX files here? Okay, please upload the PDF. Change the submission to PDF here. Okay, I'm going to write comments, but now when I've told you, before writing comments only you change, because I can't grade it without changing it to, I have to have PDF here. Okay, I can't see PBIX file. I have to download and again import. It's not possible. Please upload PDF only PDF files. And here also, if you have uploaded any IPYNB file or anything, please refrain from uploading any IPYNB file. All PDFs. PDFs should be here so that I can grade here. I can't see any IPYNB file from here. Have you understood? Is that clear? The first 3 practicals are graded for your internals. The second internal I've taken for your 30 marks, and the rest of the projects also you have to complete and submit during the practicals. That will be directly certified during the journal. Have you understood this? Is this clear? Please, if you have uploaded PBIX file for the Power BI, please upload the PDFs. I can't correct the PBIX files. Okay. So if you don't upload, then I cannot grade you on that. You will get 0 in that 10. So please inform this to your classmates as well. I'll try put a message in the group, but yeah. So I'm supposed to inform you in the class. Okay, so this is the, okay, so 7th practical, I'm just, because we had done and it was in the class, it was it was processing and it was not complete. So I have completed that. Now, there was a problem in the optimization of one code for the stop words, okay, the stop words. So what I had done, I'll tell you, this stop words I had created, I had recorded the stop words inside the loop. Because of that, it was creating, it was getting stuck. Now, without that, it's working fine. So after taking out the stop words, I'll just go through the project from the beginning. This was regarding an NLP, natural language processing. I hope you are able to see my screen properly. This was a mental health data set where there is a script associated, which is the information which the patient is saying to the doctor. That script is there, and we have the diagnosis of the mental health. If you have any question, please ask. Okay, so here you can see we have imported this libraries. First is the library for the NLTK, or for natural language toolkit, which is used for natural language processing. Then I have used pandas. Then we have the process. We have the different steps for natural language processing, or the text processing, which we say. The first step is called tokenization. So there are two types of tokenization here. One is called word tokenize. That means if a sentence is just divided into words. So how it is divided into words? If there is some kind of separator between the words in the sentence, like space or comma, it separates the data into words. But here, only separator like comma and space is considered. No other thing like full stop or punctuation is not considered for tokenization. So we also have this regex tokenizer. So regex tokenizer is something which uses regex. Regex means regular expressions, and regular expressions takes patterns or some kind of characteristics which denote that what you want to remove and what you want to keep in the data. What kind of pattern you want to keep in your words, that you can write with the help of symbols in the regex tokenizer. Regular expressions are there in all programming languages across all domains. Like you have from starting from Linux to C, C++, Python, Java, everywhere regex is there. The patterns are the same over. It's a standard patterns. Like we have /d for digit. We have square, in square brackets, we have small a to z for alphabets, lowercase alphabets, capital A to Z for uppercase alphabet. So these are standard across all domains. Okay, there's nothing special for Python. It's there in all domains, including operating system commands like Linux, now Mac OS, and so on. Next, we are talking about we from the ones we remove divide the sentence into words. We are extracting the stop words from the sentence. The stop words means the words which are pronouns or uh, you know conjunctions, interjections like is, be, a, the, all these things, articles. We want to remove that from the text as well, as they do not you know they do not reveal any context. They do not depict any context of the text. Next, we have WordNet lemmatizer. Just give me a second. Yeah, I'm just give me a second. Yeah. I'll just close the extra tabs. Just give me a second. Yeah, I was just doing the test also here. I close something important. Anyway, let it be. Okay, after this, we have imported this word cloud, which shows me a plot which shows the important words in my text. And then we have done any kind of logistic regression. So these words have to be converted into numbers, and we use this count vectorizer here, which I told you there are different types of vectorizers. Vectorizers are the things or the techniques which are used to convert words into numbers. So we have count vectorizer, we have one hot encoder, and we have TF-IDF vectorizer also. TF-IDF. Now all these techniques I have already covered in my previous class. TF-IDF vectorizer. So all these vectorizers are there, which are used to convert the data into numbers. Next, we have the train test split, and we have used random forest classifier, and we have used logistic regression. You can also use KNN for the classification. So this is the data which we have taken, and yeah, this is the data which we have taken. I think the TF-IDF vectorizer. Give me a second. Spelling is I small. Yeah, I small, and then you the text. So this is the data which we had, and we had dropped the first column, which is unnamed. And then we had done the value counts here to showing that what are the different types of mental disorders which are there. Then I had done the missing values analysis, and missing values analysis shows that there are 362 missing values, missing statements, which we want to remove using drop NA. So the statements are removed, and then we see the shape, and 52,681 records are there. Then we had done EFO. This was not required. This is just to show that how many, what happens if we want to, instead of text processing, we are using just pd.get dummies, treating them as categorical variables, because this is not a categorical variable. Okay. If this is a categorical variable, this whole statement becomes a column. Okay, so that is what it becomes. So we do not want to do this. Okay, so in this case, we are not treating the text as a categorical variable because it is not. So you shouldn't do this. I've given this here just to give you an example. And it gives me 51,000 columns, which is just absurd. Okay, next I'm doing text processing, in which we are converting the sentences into tokens. So for I in DF statement, and I'm using regex tokenizer instead of word tokenizer. If I take word tokenizer, the punctuations will not be removed. Okay, so here regex tokenizer, in which I can mention that what are the characters I want. So A to Z I've written, or small a to z. So only alphabets I mentioned. Plus means more than one time the alphabets can occur. So that if instead of that, we can also take word tokenizer here. So just see the word tokenizer here. Word tokenize. You can just write word tokenize. is going to convert the statement into words, just considering the space between the sentences, because the data here is like this. Oh my gosh, there is a space and it gets converted into words. Okay, and here it is going to convert into words, but it is going to eliminate the punctuation. Here we have to, if you are using word tokenize, you have to use another function for removing the punctuation. Okay, so you can see here we have got this, and you can check this df token word now, because I have df token word and dot head you will be able to see the words here. So you can see here these punctuations are still there. It is not removing the punctuations. So in contrast to this Rogers tokenizer, if we are using, you are going to you can see you are going to remove the punctuations as well. Next, what we are doing, we are converting everything to lowercase, and you can see everything I've converted to lowercase. In contrast, here some of them are A and all are there. So they are all converted to lowercase. So we have done this. After doing this, we are going to use the stop words, and which was getting stuck last time. Okay. So it was getting stuck. So here you can see only thing I have changed is stop words. I have kept it inside the loop. I have kept it here. The code I have kept it here. Here first we are downloading the stop words. The top words are downloaded first. So stop words equal to set stop words dot words English, because stop words are there in different languages. There are many languages, French, English, Spanish. Okay, so all the languages are there. Instead of doing this in a loop, again and again accessing that dictionary and using them in a loop, first we have downloaded the stop words here. Stop words equal to set stop words dot words English, and then we have used this here. And you can see immediately it happened. So these words like my, okay, then we have what else we had, all of, all these things will get removed here. So if you want to check the stop words, so df no stop words, if you see, this is the column in which I have stored it. And if you see the head of this, and you'll see, you can see my has gone, all the is, then everything has gone. Okay, still I have this w. Okay, so this is, I don't know why it came. You have to see what is the word. You have to check if you think each you want to remove some word and make it null, you can do that manually. Okay, so you have to see that, especially if one character is there. One character, no, I think there should not be any word with one character. Okay, anyway, so next is we can check this head, and we have this text. Then we are doing the lemmatization. Lemmatization means taking the words into the root word. Mostly it removes the S. For example, if it is works and work, it will remove the S. Like here you can see it's been, so it has removed that apostrophe, but S is still there. You should remove this S. Like M, you will see M, S. These things should be removed. M and S, one character, some data should be removed. So you have to write, I will give you in the assignment, you do that. Apply that. So after this, we are doing this lemmatization in which we are removing this. And after that, you can see after that we have done the POS tagging. POS tagging takes up, POS tagging in all the other code, you are seeing two loops, because we are accessing the row, and inside the row we are accessing the words. But here only in the POS tagging, we are not accessing the row with the words. We are not having two loops. We have only one loop which is accessing the rows. That means the sentences, and it takes the entire sentences and does the POS tagging. It doesn't take each individual word, because to understand the part of speech tag, it has to analyze the entire sentence. So we do that, and we create this tag, and yeah, so we print the tag here. Give me a second. So this is done, like lemmatization is done. So I have in lemmatization, what is happening? Some words like A and all, you can see they are removed. Okay, I, V, it is also gone. These are all gone. In lemmatization, I am is also gone. Okay, so this lemma text have removed some words which are one words. It's been, this is gone, but boy is converted to W. I see. Boy is there. There's a W came here. I have to check what is it. Okay, next is parts of speech tagging, in which you are going to keep this like you have a part of speech associated with each word, like my is a pronoun. Okay, here my, how will it come? You have to apply the part of speech related to lemma text. So let me see this. So NLTK POS tag, this, let's do this, and TF POS tag. So if you do it with the lemma text, it will give you only the words which are there in the lemma text, not in the lower token. And after that, are you following? Yeah, please write following, because again I'm having some a monologue. Difficult to understand you're following or not. Please write following here. Following, please write here. Okay, this we had done last time, but I think we were stuck in between, so I'm just repeating this part. Okay. So here, after this, what I have taken is, after doing the POS tagging, I have taken only the adjectives, because I have taken noun before. I don't see any good nouns here, because in the mental health, I want specific words like wellness or good or bad or, depressed, all these kind of words which are not coming in the noun. So I have, extracted only the adjectives here. JJ is the adjective. Okay, I tried extracting JJ, and I have added them in the ADJ tag, adjectives tag. Okay, so this I have done, and in this case, it contains words like restless, strong, worried. That is what I wanted. Yeah, this is what we wanted. I don't want any kind of words like date, time, all these kind of general words. So I wanted some kind of words which are related to mental health, so that we can understand the context that this is mental health. This text is regarding mental health. I should be able to understand that. So here you can see, and after that I have done this word cloud, and this is the word cloud. Last, good, bad, live, happy, many, hard, first, real. Okay, some things related to sick is there, mental is there, sad is there. So this I have done. I've taken 10,000 words here. Actually, this can become bigger also. Can become much bigger also. And then after doing this, what we have done here is I have converted this into numbers and did the classification. Okay. So like is this complete? Okay, we'll do this once it's complete. After this, you can see this lemma text I have taken in a single string because I wanted to convert the words into a vector, a bag of words. Bag of words is a vector in which it's a matrix basically, in which you have the same number of rows as you have in the data set. So data set I have 52,000 something, some rows that will remain. Okay, that should not change. But the number of columns here is equal to the number of words. So each column will have one word. That is what it is. So what we have done here, we have traversed the lemma.text, and we have just added each and every word to X. And this X, each and every word with a comma in every sentence, and then I have added it in the this list. First, each and every word in the sentence is added with a comma, and this entire comma is again added to a list. That means I have a list of sentences. Each sentence consists of a list of words with a comma. Okay, so something like that. And that format you have to maintain to convert it into using count vectorizer. Otherwise, you can't convert. Okay, so that is the uh, format of count vectorizer, in which each sentence will be a string of words. It's done. Okay, so this is done now. Now each sentence will be a string of words. So you can just do this now. You can write one thing because I can see there are some words which are some lists which are empty. So if it's empty, it should not be added here. So each I is basically a list. Okay, so the list is converted into text with the help of comma. Okay, I can't do anything here. Already there, I can't do anything here. Okay, so I'm just running this. And this is the string we are getting. Oh gosh, trouble, comma, sleeping, confused, restless. This is the format in which I need it's called a bag of words. Okay, so after this, I will convert it into a matrix format using count vectorizer. Count vectorizer, what it will do, each and every word, which will keep it as a column. And each column, for each row, it will check that word is present or not. If it is there, it will write it as 1, the rest will be 0. So most of them, the words are not repeated in the other sentences, other rows, so it will be 0 only. So it is going to be a sparse matrix. I'm going to show you the matrix if it is possible. Let me see. So I've done this V, and this is a vector. V1 is the vector. Okay, and you can do this two array. Now this two array converts it into a format of the array where we can see it. Now you cannot see because this is compressed form, but this takes too much of memory. If you are using Colab, you can work on it, but in my machine, I think it gives a memory error or something. Yes, it gives a memory error because of the amount of memory it is using. So otherwise, if you can see it, I mean, if you do it in Colab, or I have to close all the applications and do it, and then we can save it in a CSV file also, and you can see it. Okay. After this, what we are doing here, we are converting this. Now, I don't require to convert it into an array because I can use this V1. This V1 is enough. This is a feature. V1 is the feature for me. It's not we don't need columns here. We need this vector, this matrix, which consists of 52,681 rows. That is same as the row of the data frame, and 58,200 columns. Now you can see this and logistic regression. And we have done this prediction with logistic regression and classification report I have taken out. And you can see this. and we are getting around 75% accuracy each and every. You can see the stress, the accuracy of stress is less. Why? Because maybe the balance, the amount of rows which are related to stress are less, because of that, because it depends on that what is the bias you have. Now, otherwise you have to use here a package called SMORE, which we use for balancing. But right now we are just doing the basic. If you want to do on your own, I can add it as a extra question. You can try, see how to do SMORE. If you face any problem, you ask me. I have a project on SMORE in my Kaggle also. You can look at it. It's for resampling. Like for example, DF status, right? Here we are writing status and dot value counts. Now here stress is showing less. Why? Because the number of rows which are related to stress are low. Stress is having the lowest row count. Stress and bipolar, they are having the lowest row count. And because of that, and personality disorder, because of that, the accuracy is coming, is difficult to detect, accuracy is coming low. You can see bipolar. Bipolar is still showing 81% accuracy. Stress and personality disorder, these two are showing the lowest accuracy, because so you have to use resampling techniques where you can create new sample rows and make this make the number of rows equal to as that of the other majority rows. Okay, so that will help in the for the only for the training set, only for the training data set, not for the test, so that you can have a better training on the training of the model on these smaller, you know, smaller percentage of rows. I've done random forest also, and this is the classification of random forest. I hope you have understood this. Random forest is a, we see the accuracy of the random forest. You can do KNN and also you can do decision tree also and see. This is the classification and NLP. These are the text processing, all the processes we have covered. Okay. So if you have understood, just write understood. This I am going to upload in your classroom. And now I'm going to do a new topic. I mean, a new project. Everybody has understood this. Kunal and who are there? Just let me see. Hera is there. Kunal is there. Lester, Munal, Samson. Have you understood? I think you are not present in the last class, so yeah. Okay. So today we are doing another very interesting project, and it's called object detection. So object detection is a very important topic in health analytics, because it is used. Object detection, of course, it's not only an important topic in health analytics, it's an important topic in computer vision. Okay, because with the help of this you can locate, you can write, you can detect, not only identify the class of the object, but you can also identify that where the object is located on the screen. So you have a, for example, you have a scenery and in you want to locate the car. Look, what happened? In the previous class, you were not present. I know that. Yeah. But I explained the entire project only today. I only didn't explain the theory. So we have a few classes left. So I would request you to be present, because they are important. That's why I'm doing, right? Otherwise, I have told you, okay, we just sit for the exam. You have done enough. So now, so this helps us to understand that where the object is located. Like for example, a airplane is flying, and you want to locate the where in the space it is located. You want to identify the location. Identify the location of a drone, of an enemy drone. Okay, for an enemy army, you want to locate the place where it is located. So it's very much used in defense. And here in medical science also, here we can actually locate the um, identify the location of a tumor inside the organ. So I do not want to only understand that a tumor is there or not. I also want to understand where the tumor is there, what is the size of the tumor. So if that is the objective, then you have to use this technology which is called object detection. Okay, so we are not going to do this from scratch, though I'm going to show it from scratch. I'll tell you how to do it from scratch also, but I am going to use API here. I'm going to show you API with the help of which you can easily do this very easily. So what is object detection? Object detection within computer vision involves identifying objects within images or videos. So inside the videos, for example, how easy it will be if you have you can identify, for example, you have lost something in the office and you do not have to go to the CCTV and check each and every video footage. Instead of that, if you just give the time or the picture of the object, it should be automatically locate the video. But still, it is not there. Okay, that kind of application is still missing. Here in the car surveillance, yes, still the things are there. Like you want to track a particular car which jumped a signal or something, that can be located using object detection. Or what is the car number or the car number plate that you want to locate, that is that can be done with object detection. So these algorithms commonly rely on machine learning or deep learning methods to generate valuable incomes. So object detection in image. So instead of classifying which type of dog, as of now, we were doing that classification of an object. That means checking an X-ray image and seeing that whether fracture is there or not. But where fracture is there? Now I'm saying something more. I want more of details. That is, we have to find out where is dog present in the image. It is at the center, bottom, left, or so on. We also have now generally we have single class object detection in which you are able to identify only one class of image. You can also have multi-class object detection in which you can identify multiple classes. Like you can identify a dog also, you can identify a card also, multiple objects in the class, in the image, same image. So here we have two types of algorithms here going on. One is object classification, which is the image classification algorithm, which we have already done. That is done through deep learning. Okay. We have more complex algorithms actually. We have CNN, also convolutional neural network, which I have not done this term because you already have that in deep learning. Okay. So you are going to cover that in deep learning. So I've done simple and ANN artificial neural network images here this time. So you can go through that. So that we have done object classification. And we also have done, okay, then we have object detection. Object detection means two types. One is object classification. It combines object classification plus localization. Localization means where the object is localized or object is located. So broadly, we have three tasks for object detection problem. Identify if there is an object present in the image. First, we have to know that the object is present in the image or not, whether 0 or 1. If the object is present, what is the object? Which type of class? It's 1, 2, or 3. Where is this object located? Okay, where is this object located? So three types of work you are doing here. Why object detection matters. Now, what is the application of this field? First is safety. It helps us keep us safe by spotting dangers and intruders. Driving, it's crucial for self-driving cars to avoid accidents. It needs to understand what is the object on the road. Is it a human being? Is it a bumper? Is it a some some trash? So that it can take that action, whether it should skip it or whether it should just go through it or whether it should go over it. Okay, so that kind of decision it needs to take. Shopping, it helps us store, manage projects and understand customer. Shopping in this is very much used in shopping carts in the other countries where it is completely automated. Like there are manless counters where actually no one is there to bill your shopping carts. You just have to add the items in the shopping cart and the objects are automatically identified and they are billed and you get a bill. There is no man or it's like no people there in the counter. It is automated, completely automated. And that kind of shopping you can do. Then healthcare, doctors use it to find diseases in early in medical images. So now with the help of this, apart from when doctor is not available, you can just go through bulk X-ray images and can identify which one of how many of them have tumors or any kind of anomalies and where it is located. Manufacturing, it ensures products are made early in factories. Steps of object detection, looking at the picture. Imagine a computer looking at a picture. So it is not a human looking at a picture. When a human looks at a picture, it looks at the features. Like human looks at anybody's face, it will look at the nose, the eyes, the lips. But here, when a computer looks at the picture, it looks at the pixels, it looks at the intensity of the images, it looks at the colors and patterns. Okay. So here one thing is we don't need a very high resolution image to process computer because pixels, whether it is low resolution, whether it is high resolution, the relative intensity is mostly the same. Okay, so whichever is darker and resolution doesn't matter. So even if you're a very low resolution image, machine can identify it perfectly. In contrast to humans can't identify blurred images. Guessing what is there. Based on these clues, it makes guesses about what might be in the picture. Checking the guesses. It checks each guess by comparing it to things it already knows. Drawing boxes. Now here, this is called, this algorithm we have, which is called bounding box algorithm. Okay, bounding box algorithm in which we are wherever, for example, this is a play space and I have something like a dog or a rabbit or whatever. My picture making skills, I don't know still there or not. So for example, this is a dog. Okay, so and so it actually draws a bounding box here, like a square, which shows that I mean there is an object. Making sure it finally double checks its guesses to make sure it got things right and fix any mistakes. So like this, it will draw a rectangle here, and we have this rectangle which shows. So here we have this rectangle, and we are actually recording this coordinate and this coordinate. So here we have x1, y1, and we have x2, y2. So these two coordinates we require. So x min, y min, and x max, y max. These four coordinates we require. And apart from that, we also we will have a class value. That means what is the class here? If there are multiple classes in this data set. So this is class number 1 or 2 or whatever. So you can understand we have four coordinates here. So these coordinates correspond to the square of opposite diagonal coordinates of a rectangle. So you can see here the input image, and the input image is this. So this is the box actual input image, which is written by red color. Okay, red color box. And red color box, it shows me that the coordinates are 40, 20, 210, 180. And the class is 1, C1. And then it's written as 1 and C2 is 0. But here in the, and this is the probability, it is 100%. And in the, this is a prediction where it shows 0.8 is the probability, and the box is shown like this. You can see it doesn't cover the card completely, but it does detect. And the other things are same, only the box is a little bit not absolutely coinciding. 80% probability around. Is it clear? Write clear in the chat so that we can understand that you are listening to this. Okay. Others also, please engage. Write clear, understood, whatever. Okay. Next, we are talking about the evaluation. Now, as of now, we were using the different types of evaluation technique like confusion matrix, classification report for understanding that whether the class which the system gives is correct or not. Now we have this system called bounding box. How to evaluate? How to evaluate this? So we have this evaluation technique which is called intersection over union. Intersection over union. So there are two techniques. One is union, another is intersection, and we are taking a ratio of this. Now you understand how we are doing this. So consider this is the original bounding box. This green is the original bounding box. That means this is the original object. And if you are doing it during the training, you have already given this box to the machine that for training. Now, whenever you are doing the testing, doing the prediction, it gives you this red color box. Okay, this box one. And this red color box, you can see if you are doing the original green color box. So it is around here, right? This is the green box, and you are talking about the red box. So we will consider the intersection or the common part of both the boxes. So here we have two bounding boxes, box 1 and box 2. Okay, so this box 2, if I ask you which of this box is more accurate, the obvious is box 1.
Hello, Hira.
Yes. Hello. What happened?
Sorry, ma'am, I unmuted by mistake.
Okay. Can you see the screen? Can you see the screen, Hera?
Yes, I can.
Okay. So here, so we are considering the original box, which is the original bounding box. It may be like this and this box. So here we are taking an intersection of this box, intersection of these two boxes, and whichever box is giving more higher common part, that means intersection value is more. Box 1, like you have box 1 and box 2, and box 2 has less. When you do intersection of box 2 with the original box, you will get less amount of intersection, that means common part. And if you're doing box 1 with the original box, you will get more intersection. So this is giving more. So this gives you more accuracy over intersection. Okay, so this is for the intersection. Now we are considering intersection over union. That means I am considering the union also. Now let's see why we are considering, why we are not only satisfied with the intersection and we are going with the union as well. Now consider a scenario like this. So yes, this is what we were talking. So we have box 1 and box 2. So which one is more accurate? Box 2 is this one, this box, and box 1 is this one. So you can see box 2's intersection part is only this much. Well, box 1 intersection part is more. Obviously, because it has more common with the original box. So box 1 has more probability. This one is more accurate than the box 2. Okay, so this is about the intersection. Next, why we are considering the union. So the bounding box that has a higher overlap with this is what the intersection we are talking about. Bounding box that has a higher overlap with the actual bounding box is a better prediction. Now this overlap is called area of intersection. For this first box, which is box 1, we may say that the area of intersection is about 70% of the actual bounding box. Whereas if you consider box 2, the area of intersection of the second bounding box and the actual bounding box is 20%. Scenario 2, let us consider another example. Suppose we have created multiple bounding boxes or patches of different sizes. So here, now, okay, so here we can see, okay, now here this is a scenario in which I have drawn a box. So this is the original box and the box is so big like this. It covers a greater area and which shows an area of intersection 100%. And there is another box which shows a lesser area 70%, but this is more localized than this because this shows a more general area. So in this case, which one is more accurate? Still here, it is, though it is more intersection, it gives me 100% intersection, area of intersection. It is not very correct because this is more general. Okay, it is not localized, it's covering a more area. So in this case, we would want this box. Okay, so we have to add another matrix over here. So here intersection of the left bounding box is certainly 100%, whereas the second image, the intersection of this predicted bounding box is just 70%. So at this stage, would you say that the bounding box on the left is a better prediction? Obviously not. The bounding box on the right is more accurate. So to deal with such scenarios, we also consider the area of union, which is the patch area as well as the actual bounding box area. So here we are considering this patch area, which is yeah. So this is the patch area, the box area. So area of intersection divided by area of union. So patch area means it covers both the boxes, the entire area covering both the boxes. So that is the area of union, and we divide the area of intersection divided by the area of union. Area of intersection here will be this. Only this part, and area of union will be whole this part as well as box 1 and box 2, the entire thing. So we divide and this ratio gives us a matrix which gives us the accuracy over here. So area of intersection divided by area of union. Yeah. So if you have no overlap at all, the area of intersection will be 0, whereas area of union will be the sum of the area. So overall IOV will be 0. Similarly, if you have 100% intersection, area of union will be the sum of the area. So overall IOU will be 0. And both of these have no overlap at all. If there is no overlap, the area of intersection will be 0. This I told you, right? I think the same thing. Yeah. So next is how do we do this in the in machine? We use the OpenCV library. We can use for object detection. This is the algorithm which we use. You only look once or YOLO. This is for multiple box detector. Okay, these models you can treat. Okay, so there is a library called Ultralytics, which we need to import. Okay, this is used for these models, the object detection models. And but I am going to show you using API, which you can use. But this has a credit limit. So first time you can use for trial. After that, you have to use a different account or you need to open a paid account. Okay, so there is also a technique called template matching, which is a high-level computer vision approach that detects image portions that match a predetermined template, which is very important in medical image analysis. If you want to match an image with a predefined template, like for example, a chemical with a predefined molecular template or something. So in that case, you can track that with the help of, suppose you want to track some chemical inside the medicine, and you think that pharmacists were using that previously in the medicine, but now you have found with research, you have been found that this is poisonous. So you want to track all the medicines which have this chemical. In that case, you can use this. So for example, this is a template matching. So for example, this is a template, and you can match this in your image. Purpose of template matching: it is a way of searching and locating a template within a larger image. The goal is to discover identical portions of image that match a template. The threshold determines how well you can recognize the template in original image. Okay, I'm not reading this, so you can just go through this. 1-stage and 2-stage deep learning object detectors. Like here, okay, so here 1-stage object detection, there is you understand, in the bounding box, you have to, if you have to locate or you have to predict the bounding box, the bounding box has 4 numbers. So x1, y1, x2, y2. They are numbers. So what will be used? We are using regression, okay? And we have class for the classes, we are using C1, C2, we are using classification. So this is 1-stage object detection. Okay, we have 2-stage object detection. First, we give a proposal, and from there we are getting the regression box, and proposal is like a template. Conversely, perform 2 steps. First step involves a region proposal network that gives us the region of interest, whether an object might be present. The second network then uses this region of interest to produce bounding boxes. Popular 2-stage detections using RCNN, faster RCNN, mask RCNN, and latest model GRCNN. So we have 2 types of object detectors here. 1-stage object detector, which we are going to use, that is the most basic. From the data, we are directly creating this bounding box and classification. You also have 2-stage object detection, in which first we are scanning the image and we are creating a region of interest. And from that region of interest, if the object, which says that the object is present or not. If the object is present, we are generating this regression and classification box. Okay, so I am going to show you this live. I'm going to upload this data set for you, and I want you also to do it because otherwise there's no point. Okay. No coding is there. You just have to do it in the machine. Where am I going? Yeah, this is the classroom. Are you able to see? How many of you have logged into the machine? Understood, right? Okay. How many of you have logged into laptops? You logged into laptops, please write yes. The classroom, and I'm uploading this here. This is an object detection dataset. So I'm using a brain tumor dataset. Uploading this. Going to healthcare, and the dataset's name is axial. Yeah, this one, MRI. So I have these 3, this. So I'm uploading this entire thing. So it is saying uploading file. I have to upload the folder. Can I upload? So let me see where can I upload it. If I have it in my drive, I'll send you the link. I think it will be there. Yeah, this one. Okay, so this, I'll just check the link of this copy link. I'm copying the link and I'm putting it in my drive here. And I'm adding this link here. Let me know if you can download, posting it. I think I need to give sharing rights also. How to change the sharing rights? Okay, so I've done this. Let's see whether you can download it or not. Okay, next, what I want you to do, you want to create an account in RoboFlow. Okay, so I have already created an account, and let me see if I, because this accounts all have a credit limit. So I've already done one project. I'll just try see that whether it allows me to do another project or not. Okay, so one credit is already done. So just see here. Now I'm going to show you the steps. The steps you have to, now for this project, what you need to do is you have to copy the steps in or the screenshots in the PPT or PDF, whatever. I am also doing the same right now. I'm opening a PowerPoint and I'm copying the steps. So this is an API which you need to use. So I'm using, this is object detection using RoboFlow. So first what you need to do is you need to create a RoboFlow account. Okay. So you create a RoboFlow account. I'm just sharing another link with you. Go to this RoboFlow. Yeah. So it will give you a prompt like this, I think. Yeah. So here, app RoboFlow login. This is going to give you a link where you need to create an account. See, otherwise you have to do this on your own. Now I'll explain the data set on your own means you have to write code from scratch. So here, yeah, code from scratch. or ChatGPT also fine, but instead of ChatGPT, this will save a lot of your job because automatically it will be done. So here I'll show you the data set now. What is meant by the data set? So this is your data set. Okay, so we have three folders: train, test, and valid. These three folders are there. I'm going to train, and train has these images. You can see there is an images. So some of the images, there is a tumor in the brain. There is a tumor. Don't think that this is a tumor. This is not. Okay. So some of them does not have tumor. So you need to identify which one has tumor, and if it has, where is the location of the tumor. So this is the image of a brain, basically. Just give me a second. I have one. Images. Okay. Now we also have these files, which is called the annotations. Now you can see if you want to use, there are two types of classes, negative and positive. This is the names of the classes. And this is the annotations. So negative means 0, positive means 1. Now I'll explain this. First, this is the name of the image. This is the name of the annotation file. First starts with the name of the image. That means this image has to be somewhere here. You search this image here. So this image will be here somewhere. Here. Yeah, this is the image. Okay, so this image is there somewhere. Okay, so in this image and based on this file, which we are looking at here, you can see there are this box. This is a box, basically. I told you the opposite coordinates, diagonals of the rectangle. So this is a box which denotes that where the object is located. The coordinates are as per your screen. Okay, the x1, y1, x2, y2, and this says 1 means the tumor is there. Okay, and 0 means, but if there is a 0, why there is a box, then what does it mean by that? I mean, you have to check that what is the meaning of tumor here. Yeah, for this you need to have a little bit of domain knowledge. Let me just search. It's called axial tumor, okay? Axial. So it is in the cerebellum. Okay, so cerebellum is has to be there in your brain. Cerebrum and cerebellum, they are the components of the brain. So it occurs in the cerebellum. So this denotes the location of the cerebellum. Cerebellum is obviously there in all the parts of the brain. I mean, all the brain, not all the parts, all the brain, cerebellum is there. But you need to understand that this tumor, the cerebellum has a tumor or not. So location of the cerebellum is mentioned here. Okay, so I hope you understood this file. Now, what you have to do is, in case of you want to do it from scratch, you have to take an image and you have to draw this box for each and every image, and you can plot using a plot. Okay, so that you can do with the help of a rectangle, which is a shape command. It's not difficult, you can do it. Okay, and plot also you know how to do it. So you have to actually go via this file. This is a CSV file, which is not at all difficult. You can read the CSV file, and first column is the JPG. You can try this also if you want and create a grid plot from this. This is also an exercise you can do. Okay, now I'll tell you how to do it here using the API. Have you created, anybody created a account here? Have you created an account? You did, good. Good. Okay, so once you created an account, now you see here, for example, I have logged into this account and I'm going to project. So I'm just taking the screenshots and I'm going to upload it. So this is my account. You have to create a workspace first. So I'm just taking a screenshot of this. Workspace. And what I'm doing here, I go to projects here. I go to, see, already I have created a project. I just practiced just before this. So I'm creating a new project here. And you give the name here. Serial brain tumor detection. Let's keep it public. It's object detection, okay? Which is multimodal, it's bimodal basically. It's not multimodal. So I'm not selecting this. Okay. I'm just creating, not sure which type, it's okay. Create public object. So here you can actually do bounding boxes. Now you can see this cars. You can track the cars and their motion in the video. You can see how the cars and their motions are tracked in the video. Now I'm creating this public project and just give me a second. I'm just, did I create the project? Okay, so this is a project. I should have taken the screenshot. I'm not. Anyway, this is a public project. So I've created a project here. Object detection project. Yeah, I'm deleting this. Next, what we are doing here, we are uploading the data. So we are uploading the entire, I will upload the entire batch here. So instead of selecting each and every year, here we have images, annotation, videos, PDF, over. So I'm just selecting the folder. Just selecting the entire folder. Okay. So that it can upload the train, test, whatever. I'm not doing any work myself. You can see it automatically has detected. This is annotated. This is training data, so it was annotated. And these annotations are done. So somewhere it is red means yes, and I think blue means no. Are you following, everybody? Yeah, right, yes, after following, if you are. So I have uploaded the entire thing here. This is your data for training, and we have uploaded. We are creating the data set. You click on upload data basically. This project's practical has to be done like this only. You upload the screenshots. And I should be able to see your names proper. Write your proper names here. Okay. And your name should come in the workspace. And if it's a public, you can give me a link as well. So once it is done, what I'm doing here. So now you can see this. Now save and continue you have to do. Now you can see here also you can check. We have seen that how to create a batch from the images, like we use Keras image datasets from directory, that command. So here you can see it creates a batch here. You can also write create batch instantly from here. Or it will ask you how to create a batch. So you create batch instantly. You can see this is the annotated. The annotated means the images which are annotated here. There are 371. All the images here are annotated. Even the test images are annotated. Okay. So you can check this and then you can do save and continue. So you can see this is the, you can write here. You can check the report over here. How many annotated? You can check the your folder and see. If you want, you know how to check a folder, right? So import os.listdir and check the length of the images in Python. Like we can do the same thing in Python and we can verify. Like for example, where is my Python? I put it here. So you can actually check the image folder here. Import OS. Bring the path. And you write path. Right. So these are the images, okay? Now you can see if you want to check the length of train, so you will find ki how many images are there. 59 images are there in that in train. Then we had test also, right? And validation. Test has 41 images, and then we had validation images. And you can see valid images. Now you can see 83. So total number of images which we have is 259 plus 41 plus 83. Sorry. 59 plus 41 plus 53, which is 383. How many images it was saying? Some three more than that, I think. So 371. So 383 here, some less, some images are not read. Okay. So some images, those might be a problem and it was not read. Is this clear? Is this clear? Are you understanding? Okay, now you can see here. Continue. Now you can see it's written. This is what train is 253. Validation is 79, and test is 39. That is how it is sent. Actually, how much it is? Actually, you have just read it in Python. I'm just confused with the tabs. What is the tab? I have to check this. So here it was 259, 41, and 83. Now you can see that which one is not read. You can easily see here. Just closing this. Instead of 259, 253 images were read. 81, 79 images were read, and there 41. So two images less are there. That's okay. Okay. Some problems might be there with the images. So here you can see it's written. But if you want to change this, you want to put more in the training because we all have the images. It can I mean, you can shuffle the folders. So if you want to increase this a little bit, you can. Okay. So I am splitting, writing the splitting here. And I'm clicking on continue here. Really, it is going to it is creating a data set. So it will take some time. Not a lot of records are there though. Now you can do this in the machine also using ANN, which how you have used the fracturing bone fracture data set. That also you can do it here. Anybody else who is doing it live with me? Did you try? Anybody is trying in the actual RoboFlows, website? Okay, Krishna, yes. Anybody else apart from Krishna? Anybody else created an account? Okay, now you can see. So here it shows that no version is created yet. Means you can't still train. Okay, you have to create a version, and this is your version. This is your report. Okay, so create a new version. So what we are doing, we are creating a new version. So this is also a very important step. So I've splitted the data, then I'm creating a new version of the data set. Now, why new version? Because here, sometimes what happens, only this data if you give, it may lead to overfitting. Okay. And because to prevent overfitting, we can do augmentation. Augmentation means giving the images in different forms. Like here, there are specific types of images are there, but we can also flip the image, we can rotate the image and just add more images in the training data set so that the machine can understand it more easily. Okay, so version name is already given here. If you want, you can write a version name, Axial Tumor 1 or something. Okay, so I've created this. So source images, train test split pre-processing. Now here, auto orient, that means resize. Now its resize is given as 512 by 502, which is actually the original image. We can see what is the size of our original image here. We have imported the data in Python, so we can do that and see what is the size of the image. So I'm importing import CV2 here and import matplotlib dot py plot here as plt. So I am taking, for example, this image. img1 equal to plt dot or cv2 dot imread do I write train path or something? Path. So it is reading the image. This is the image. Now you can check the size of the image. img1 dot shape should show you the size of the image, which is 256 by 256 by 3. Okay. So here and here it is taken as 512 by 512. You can take it original size if you want. Stretch to 512 is written. You can take it as 256 and 256. Okay, you can change it. You can change it to 256, 256, or you can change it to 32 by 32, whatever. So for example, this is the original image. We did add a pre-processing step. Pre-processing means we are adding more images by doing this kind of operations with the image. So operations are like, you can see they are flip, they are rotate, they are crop, they are grayscale, auto adjust the contrast, modify the classes, style, and so on. Okay, so these are the different types of. We can just do a static crop or isolate or rotate. Where is the rotate thing? Any one kind, auto adjust contrast. So it will be like this. So it will add more images here. Now my images increase, it will increase, okay? To add pre-processing step if you want to add. So these are the pre-processing steps for the color changes like contrast, grayscale. So I'm writing here. So pre-processing the colors. So this, if you want to do it manually, you have to add an augmentation layer. Like you are adding the grayscale or something. You want to do an augmentation. Add augmentation step. So you want to add augmentation. This augmentation layer is also available in Keras. You can do this. Augmentation is nothing but you are changing the image a bit. Like you may stretch it, you may flip it like mirror flip, or you can rotate it. So add augmentation. You can see 90-degree rotate. This becomes like this, or you can add crop. So you can add multiple layers if you want. Are you understanding? Are you getting this flip? So I'm adding the flip here. Horizontal flip, vertical flip, both are there. Rotation. You only understand when you are adding this layers, the number of images will increase. Okay? So there is less chance of overfitting because now the system can see your image in a more detailed in different varieties also. So because of that, the system understands it better. continue you do. So this is done. Next is create. So you can see the images. Before it was 399 images. Now it became 377, 877 images. You can check how it is calculated. So larger versions take longer to train, but better model. So added pre-processing and augmentation steps in get images in the training set. Like this. Okay, this is your version. You are creating this version, and with the help of this version, you are going to create the training model. Basically, we want to build a model. So now, after training, I think training takes here long, like 1 or 2 hours. Create a training model. Click on create. Okay, so create a new version. So first you created a new version. You can see this version. So version is created. So this is your data set, because now you can download this data set because you have some make like augmentation and all that. You can add it processing and you have new data, new images in the data. So if you want, you can download the data set. It will send you a mail in your mail ID. So I'm just writing here. Sorry, create a version. This is dataset version, okay? Dataset version, not a training. So version creation complete. Now you can download the version also. This dataset you can download and you can use in your machine also. You can use for your model. Okay, model is not created. Now you can create a model. So train model, you have to click on train model. Okay, it says that here this neural architecture search, there is a advanced model. So this is optimized. If you want to create this, this is a paid version. Upgrade option is there. Otherwise, I'm creating on custom training here. So custom training means it will assign the weights to the neural network. That is your artificial neural network. Okay, and you have to select the architecture. The architecture here we are using YOLO mostly, and RoboFlow has their own model architecture, which it allows you to use. So this is training a model. And which architecture we are going to use? You can use yellow here, or you can use yellow because we are going to use ultralytics for prediction. So here, training a model, and you can click on start training. So I've selected the architecture. Now we selected yellow here. Which model, which algorithm you want to use, that you have to select from here. Generally use Keras and all, but for object detection we use yellow. Is the spelling correct? Now you have to click on start training. Now you can see this is the version what it downloads. Now it is saying we'll make. Now this what it says it is going to mail you when it is done. So it is going to take some 1 hour for this training to be done, completed. So now you have to wait for the training process to complete. I had done a previous training. I'll just check if it is done or not. I hope you have understood this is such an easy process. You just have to now do the prediction. Once the model is done, we are going to deploy the model and do prediction. So here it shows the training and it is going to, once the training is done, it is going to show you the precision recall, everything over. And it will also allow you to download. So you can see for the regression, that is a bounding box, we are using mean absolute precision. That means mean absolute error. And then we have precision recall and F1 for the classification. Because we are using both regression and classification here because we are predicting numbers as well as classes. So I'm just writing this here and I'll see my previous training. If it is complete, I can show you that. Just trying to open up another window if it allows me. Why be showing classroom? Yes, have you followed this? Little bit still is left, but I'm not sure whether we can do it today. I'll just check the previous project. I had done the training. Now you can see here the training is there and it shows me 100%. Give me 1 minute. Okay, so here you can see this. Yeah, have you followed this? It's clear, right? Krishna, what is your status? Are you able to do the model? Would you like to share your screen or something? If you have done something. Yeah. So, yeah, if you do something, it's encouraging, right? So output is, you can see this prediction, X and Y. This is the, so X, I told you, this is the coordinates, the X, X1, Y1, and this is the height and the weight. So this is the X2, Y2. Okay, so the height, X1 plus height gives you X2, and X2 plus weight, I mean Y1 plus weight gives you Y2. So like this, and class ID is 0, that means tumor is not there. Okay, so this is for one object evaluation. See, so this is a prediction, but you can do this model actually you can download and deploy in your machine, and you can use it. So this is the prediction. You can see view full model evaluation. It is going to show you the, I think ROC. It is showing you the ROC, which is how much it is showing, some 90% or something. It didn't show you the what is the percentage of ROC. I cannot see. This is the confusion matrix. This is for the test set. You can check it for the validation set also. All are 100%. Okay. Even for the test set also, it's 100%. Okay. This is the evaluation. You can check the evaluation. I will see that ROC is there or not. Here you can just deploy the model. Deploy the model means you have to this model you can deploy and you can detect and classify, right? Detection model and classification. There is an option here to create the code for deployment. This is still the training is going on. This is for the previous model. Here. So once you deploy the workflow, you can see this is the code. You have to import this code here in your machine. So for example, I have my machine here. Your data set should be there. So this, you see this model is already trained on the data set. Okay. Now here what you need, you need only this model for prediction. The model is trained model, means it's become an expert. Now this model, if you give any data from your data set, it is going to predict your data. So first what we need to do is we need to use Anaconda here and install this. I'm just using Anaconda prompt, and I have my data in a virtual environment. So cd tf underscore env cd scripts activate Conda deactivate. When you install this pip install, so I'm just copying and copy this here. Okay, I'll check. This is Ultralytics actually. Inference SDK. Like it's probably. I will check what has happened with this. Series required. No, it is not. You could not find a version. I have to see this. Why it is giving an error. Okay, so you whatever is written over here, you have to actually use the code from here. So I have installing the inference SDK, and then we have to use this code, which is over here. So this will use the model from this. Of course, this model has to be downloaded, and you have to use this. So anyway, I have to format this. This will not get pasted like this. Maybe I require another day for this deployment. Okay, so we'll deploy it in another day. You have understood, I think, most of this thing. I'll show the deployment because I have deployed in my machine using. Can you see the screen? Okay, just give me a second. I have a. I think it's there here, but I have used Ultralytics here. This inference also, it never gave me an error, but I just check. No, this one is different. Axial tumor also I had. This is I have created today. This is the same file name. Different. Okay, so here I have to get. I mean, I have to get that notebook where I have created. I have to check. I have to check why that inference is giving an error. And that's Yeah, this is the Grammarly's depiction. This is a PDF. Yeah, this is the Ultralytics. This only you have to install. The Ultralytics you need to install. Ultralytics. This you install. So, okay, previously I used the RoboFlow model. Today I had used YOLO. YOLO has this inference library which is not allowed me to install. So I have to check what requires it to install. You have to install and deploy it. Without installation, it can't be done. The same code which is mentioned over here. You have to use this. See the same thing which I am showing you. This I have done previously in the previous batch also. So here I had used a RoboFlow library, RoboFlow model. So we had installed RoboFlow and then it worked directly. Okay. But now today I have used an YOLO model. See here, from RoboFlow, import RoboFlow. This I have done. So this RoboFlow was getting installed without any problem, but the model which I have written today, it is YOLO model. So I have to see this inference library, it's not getting installed. If it is not getting installed, I have to use RoboFlow open. Yeah, Krishna, do you want to show me your screen if you have done something? Okay, whatever I have completed, please complete this at home. I am going to upload the PPT and the deployment part we can do it next day. Right now, I'm taking the attendance.